Assalamualaikum warahmatullahi wabarakatuh. Today, me, Haziqah, Dini, Fatin and Iskandar are going to explain about set analysis that use ion-selective electrode method. So, what is set analysis? Set analysis is needed to identify unknown substance and monitor the quality in fields such as food safety and water treatment. So, what is ISE? ISE or Ion-Selective Electrode is a chemical sensor that is used to determine the concentration of a specific ion in a solution. So, what is the purpose? That is used to determine the sodium concentration in food such as butter and cheese. Next, let's go to the working principle. When the tip is immersed inside the solution, the ion-selective membrane selectively binds with the ion from the sample, which is the solution. Thus, the difference in the concentration of the target ion in the inside of the electrode, which is external solution, and the sample, which is the external solution, creates a charge distribution across the membrane. This causes a measurable voltage to be generated. Let's go to the procedure.
Okay, procedure for ion-selective electrode. Firstly is a preparation of solution. Prepare a series of standard solution of the ion to be measured with known concentration for calibration. And then electrode setup. Connect the ion-selective electrode ISE and reference electrode, often a silver or silver chloride electrode, to a potentiometer or pH or MV meter. Ensure both electrodes are properly rinsed with distilled water before use to avoid contamination. Third, calibration of electrode. Place the electrodes into the first standard solution and wait until the potential reading stabilize. Record the value and then repeat with other standard solution to generate a calibration curve. Then, this calibration curve will be used to determine the unknown concentration.
Next is procedure number 4, measurement of sample. First, we need to rinse that electrode with distilled water. Blow gently, do not rub. Second, place the electrode into the sample solution. Third, wait for a stable reading and record the potential. Procedure number 4 is determination of concentration. Use the calibration curve or the Nernst equation if known to calculate the ion concentration in the sample from the measured potential. Lastly is cleaning and storage. After use, rinse the electrode with distilled water. Lastly, store the ISE according to the manufacturer's instruction, some in distilled water, others in specific conditioning solutions.
Okay, so application in food analysis. They widely used in food analysis because they allow fast, direct and selective measurement of specific ions in complex food matrices. This helps ensure food quality, safety and nutritional labeling compliance. First example of application in food analysis is salt or sodium content measurement, used for determining sodium levels in processed food, snacks, sauces and meats. It's important because sodium content affects flavor and must be labeled due to health regulations. The next is potassium analysis, used in fruits, vegetables, juices, baby food and dietary supplements. It's important because potassium is an essential nutrient. Its levels are often monitored for nutritional labeling. For the last, calcium and magnesium in dairy products, used for measuring mineral content in milk, cheese and yogurt. It's important because it ensures proper fortification and assesses hardness in processing water.